Hello, this is Positive Tiger Gamer coming back at you with another opinion and answer short edition. This time it's number 8, and in follow up to my opinion and answer short number 7 when I was discussing gear power locomotives. This is part 2 of that episode because this is a two-part segment. We're going to be talking about in short 8, the gas and steam turbine locomotives along with fireless locomotives. So we're going to be joining into that. So folks, we're going to start this off with gas and steam turbine locomotive. So basically, in terms of what are gas and steam turbine locomotives, how they work and run on gas and steam powered turbine engines, well, folks, we're going to dive into these as we explore, so come, enjoy, listen. First up, what is a gas turbine? A locomotive that runs on a gas turbine engine to power its wheels, meaning that a gas turbine train typically consists of 2 power cars, one at each of the end of the train, and 1 or more intermediate passenger cars. There is 3 types of gas turbine engines. One is gas turbine mechanical, gas turbine electric, and coal-firing. You can go look that up, folks, in terms of those. Second question, people are probably wondering is, what is a steam turbine locomotive? A steam locomotive that is powered by a steam turbine in order to drive its wheels. In terms of advantages for gas turbine, a gas turbine offers some advantages over a piston engine. There are a few moving parts, decreasing the need for lubrication and potentially reducing maintenance costs, and the power-to-weight ratio is much higher. A turbine of a given power output is also physically smaller than an equally powerful piston engine, so that a locomotive can be extremely powerful without needing to be abnormally large. Unfortunately, the downside to a gas turbine locomotive is the fact of a gas turbine power output and efficiency both drop dramatically with rotational speed, unlike a piston engine, which has comparatively flat power curve. This makes gas turbine GTEL systems useful primarily for long-distance high-speed runs. Additional problems with gas turbine electric locomotives specifically include the fact that they are very noisy and produce such extremely hot exhaust gases that if the locomotive were parked under an overpass paved with asphalt, it could melt the asphalt. In terms of steam turbines locomotive advantages and disadvantages, the advantages to a steam turbine is the fact that it's highly efficient at high speed, far fewer moving parts, hence potentially greater reliability. Conventional piston steam locomotives give a varying substitutional torque, making wheel slip much more likely when starting. The side rods and valve gear of conventional steam locomotives create horizontal forces that cannot be fully balanced without sustainably increasing the vertical forces on the track, known as a hammer blow. And unfortunately, just like the gas turbines, there are some disadvantages in terms of steam turbines. High efficiency is ordinarily attained only at high speed and high power output, though some Swedish and UK locomotives were designed and built to operate with efficiency equal to or better than that of piston engines under customary operating conditions, including part load. Gas turbine locomotives had similar problems, together with a range of other difficulties. Peak efficiency can be reached only if the turbine exhausts into a near vacuum generated by a surface condenser. These devices are heavy and cumbersome. Turbines can rotate in only one direction. A reverse turbine must also be fitted for a direct drive steam turbine locomotive to be able to move backwards. So basically, in terms of a steam turbine, they can only move forward because of the turbine motor going in one direction. In order to go backwards, a reverse turbine has to be installed on the locomotive to be able to go backwards. And in terms of real-world examples, for gas turbines, you can look at the Swedish and Czechoslovakia for mechanical gas turbines. Examples, electric gas turbines, you can find them in Switzerland, Russia, and Canada. Coal firing and gas turbine electric could be in the United States, gas turbine mechanical and electric in France, and you can find all 3 gas turbine mechanical, electric, and coal firing in United Kingdom. So that does it for the gas and steam turbine locomotive section of our opinion and answer short number 8. But we're not done yet, folks, because we are going to talk about the fireless locomotives. In terms of fireless locomotives, a lot of people probably been wondering, what is a fireless locomotive? Because it should have a fire, it shouldn't in order to move. Well, guess what, folks? They are one of the most interesting and weird locomotives designed because they do not run on diesel, but does run on steam. But not one that burns coal, but not one that coal burns to produce the steam to move. So what is a fireless locomotive? A fireless locomotive runs on a reservoir of compressed air steam, which is filled at intervals from an external source that powers the reciprocating engine. In terms of advantages and disadvantages, you can look at it's a low production cost, so it's much cheaper to be built. Yay! It's more cleanliness, less worry for boiler explosion or fire because there's really not really much to a fireless locomotive because it's running on compressed air and not actual fuel. As they do not emit any exhaust except for steam, they can shunt into buildings without endangering the workforce with noxious fumes. They do not require careful monitoring of water levels and boil pressure or carefully distribution of coal in the firebox for efficient combustion, and thus can be operated by less skilled staff, not requiring a fully qualified locomotive engineer and fireman. Unfortunately, there are 2 downsides to these, and that is the sources are limited for refilling the locomotive in terms of the compressed air, and of course limited travel range due to the locomotive's reserve of the air that is needed for it to be run. Its purpose in life when it was built was typical usage was in industrial switching, where conventional locomotives was too noxious or risky, such as in a mine or chemical factory. They were also used where a source of air or steam was readily available. Its working life, places where you could have found them, where they either worked or were used, was the thermal power stations, refused incendiary plants, mines, chemical factories, coal-fired power stations, sugar mills, and were used for constructing tunnels. In terms of the wheel arrangements for the fireless locomotives, most were 040s or 060s wheel arrangement locomotives. Some were 080 wheel arrangement locomotives. A few were 010 wheel arrangements. And then, of course, there were some with B2 wheel arrangements, otherwise known as articulated locomotives, which based on the name of articulated locomotives, you can probably understand what they are. Otherwise, feel free to comment below if you're wondering about that. Yeah, and that will do it for our opinion in short number 8, looking at gas, steam turbines, and fireless locomotives. This concludes our part 2 of our 2-segment shorts. For those of you who want to learn more about the geared power locomotives, I would highly recommend you go check out my opinion in short number 7, where I discuss that in my part 1 of 2. So folks, join me again on another edition of an opinion in short answer number 9, which will be coming to you soon at the end of the month. So folks, stick around for that. Feel free to like, comment, and if you have any questions, feel free to throw them down in the comment section, and I will do my best to answer them all. Otherwise, folks, you all have a good one, and I will see you all on the next one. For now, see you all later, as I gotta catch that train. So bye, all.